do that, we start by finding the delay for each stage. هناخد هيدا trace stage. قلنا الديلي لها بيكون بيساوي TP0 plus times 1 plus اللود اللي عليها اللي هو CGJ plus 1 divided by its self capacitance. بس self capacitance نحن we reinterpreted it as a function of its input capacitance، يعني هو gamma ضرب CGJ. رجعنا قلنا طيب okay great, so the total delay لكينا for the chain هو delay for stage 1 plus delay for stage 2 plus the delay up to stage n, and each one of these can be written in terms of the TP0 expression with respect to the next input capacitance بالنسبة ل myself اللي هو gamma times my input capacitance. And since I don't know what are the sizes of the transistors and I don't know what are their capacitors, the best way to optimize the delay is really to do del TP by del CG for each one of these capacitors. Okay, and set it to 0. So we took an example where I'm going to focus on the derivative with respect to CG3, where CG3 appears in two terms. If the other terms do not have it, so they will automatically, the differentiation will give me 0. So I expand these terms, the two terms that have CG3. Okay, I drop out the constants and I take out the common multiplier, and I end up with an expression that has CG3 على CG2 plus CG4 على CG3. Okay, if we now treat CG2 and CG4 as constants بالنسبة ل CG3, then it's as if I'm differentiating del X over A plus B over X with respect to X, and I end up with a relationship where X over A is equal to B over X. Okay, and then I will end up finding the fact that the differentiation of the optimal delay will be related to the fact that I should ratio CG3 على CG2 بيساوي CG4 على CG3. يعني as if the ratio of 3 to 2 is the same as the ratio of 4 to 3. طيب, I can call this value F. Okay, since I have a chain it is the same. يعني 4 to 3 إذا بعمل differentiation بالنسبة لهيدا هيطلع بيساوي 5 to 4. طيب معناته هو كلهم constant, كلهم بيساووا بعضهم. يعني at any stage I'm going to end up having CG2 over CG1 equals CG3 over CG2 اللي هي CG4 على CG3. So all of this will lead to the fact that all of these ratios are equal, and I'm going to give them the common value F اللي هو fan out. Okay, فإذا I establish from the optimal delay the fact that the two consecutive stages must have some constant ratio between their input capacitors, and since I know that the input capacitance is proportional to the sizing, this means that every two consecutive stages will be the size the same. يعني إذا هيدا كان times 1, so if this is times 1, and let us say that F comes out to be 2, then this will be times 2, this will be times 4 بالنسبة للأولاني طبعا لأنه أنا I'm multiplying by 2 at every stage, and this will be times 8. Okay, this is for the example when F equals to 2. Okay, فإذا the optimal delay tells me that the ratio of the consecutive input capacitances is constant, and this means that the sizing from one stage to the other I size by the same constant factor. And now the question becomes, how can I find the value of F? طب شو هي ال F؟ نرجع للproblem. We go back to the main problem and we say, given that I have a chain with some fixed minimum sized inverter with known input capacitance, say it is a 3 femtofarad, and a final load that it needs to drive, which is 100 femtofarad in this example. This load comprises the final CGN plus 1. يعني what I know about this stage is that C load over CG1 هيدي بسميها الفان out للفول circuit، يعني the whole chain and the ratio C load على CG1. طيب بس I can by chain rule split this لأنه أنا بعرف إنه السي لود هو CGN plus 1 والinput capacitance لأول stage هو CG1. I can have a chain rule يعني بضرب وبقسم نفس الفاليو. So هيدي CGN plus 1 على CG1 هي CGN plus 1 على CGN ضرب CGN على CGN minus 1 ضرب CGN until I reach CG2 over CG1. And I know that each one of these is equal to F by the optimal delay. So therefore I end up having that F to the N is equal to C load على CG1 or F to the N is equal to big F which we called C load على CG1. Okay, so therefore given a chain of N inverters, given C load and given the input capacitance for the first stage, and I can immediately calculate F as the nth root of big F اللي هي C load على CG1. Okay, and now I know that I'm going to size each one. If this is times 1, this will be times F times F squared until I reach the last stage whose size is S is F to the N basically. Okay, S is equal to F to the N. هلا بنطلع عليه in an example. Okay, so H1 I size by times F. Okay, so the size of this is F to the N and it's equal to C load على CGN plus 1. Okay, طب this is where we reach here. So let me go back now to the slides and let us take this rule. Last time we said that F is the nth root of big F. Okay, and we gave an example. And now let me follow the slides a little bit and then we will take more examples. So let me. Okay, so let us see what the slides are bringing forth. So for each inverter, it will be sized up by the same factor with respect to the preceding inverter. Okay, and it has the same effective fan out. اتفقنا هو external load over my input cap. Okay, and this is basically CGJ plus 1 over CGJ. Okay, ليش؟ لأنه نحن عرفنا الديلي as TP0 into 1 plus F over gamma. Okay, and this represents how much F represents how much sizing is done compared to me for the next stage. طيب هلا all the inverters in the chain they have the same delay. What does this mean if all the inverters in the chain have the same delay? نحن كنا قلنا إنه TP هي summation from J equal 1 لN of TP0 into 1 plus CGJ plus 1 over gamma CGJ اللي هي summation from 1 to N of TP0 into 1 plus FJ over gamma. بس ال FJ is the same لأنه كلهم عندهم نفس ال F. يعني total delay صار summation 1 لN TP0 into 1 plus F over gamma صار فينا نقول هو N times TP0 into 1 plus what is F? It is the nth root of big F right over gamma. Okay, so now I can find out what is the total delay of this chain of N inverters. Okay, type. Great. So let me then now look at
Doctor?
Yes, go ahead.
But could you please remind me where did we use the second point? All inverters in the chain have the same delay.
Yeah. 1 second. Let me delete.
I understand the process. بس هيدي نسيت وين استعملناها.
نحن طلع معنا إنه what did we just find? We just found a little while ago that this ratio, let me just go back here. We just found a little while ago that, sorry, that this ratio here C load على CG1 هي البرودكت له. هيدي وضحت لك صح؟
Yes.
Okay, and we just found that the ratio of any -1 that the ratio of any of these for any stage, what did we find? We found إنه CGJ plus 1 على CGJ.
Yeah, the ratio is the same, but
هيدا
how is the ratio linked to the delay?
yes.
إنه the delay is the same.
يلا جايين هيدي equal to F صح؟ مظبوط؟
Yes.
طيب هلا what is the delay? What is my delay? شو delay expression for a given
tau
CGJ؟
log 2.
TP0 صح؟ لأن إحنا ما بلشنا من the delay is 0.69 ضرب RC صح؟ ورجعنا
Yes.
كفينا من هاي قلنا هي 0.69 ضرب R ضرب C self اللي هو اللي موجودة هون. خليني أرسم لك C self هون. C self plus CGJ plus 1 for this one. Okay.
Yes.
And then we said we'll take 0.69 R ضرب C self. هاي سميناها قلنا بتضل TP0 ما بتتغير قد ما كبرت أنا السيركت اللي عندي إياه. صح؟ into 1 plus CG external يعني على بدل ما أحط C self حطيت جمع CGJ.
Yeah.
So رجعنا صرنا سميناها هلا TP0 into 1 plus CGJ plus 1 على gamma CGJ اللي هي TP0 into 1 plus F over gamma. Okay? Where F is this ratio CGJ plus 1 over CGJ. Is this clear?
Yes, yes.
Okay. Any other questions?
No, thank you.
طيب great. طيب so لكينا هلا what we're going to let me duplicate this slide just in case you need to refer to it later. So now what we are looking into is to build the relation of the final delay. Okay, and the final delay relation هتكون إنه TP optimal هي N TP0 into 1 plus the root F على جنب. صح؟ حسب السميشن كلهم عندهم نفس الديلي لأنه عندهم نفس ال F and so it will be N TP0 into 1 plus root nth root of F على جنب. هلا you can now ask me, well I can tell you I have 3 stages and you will find the delay, or I can ask you what is the optimal value of N that minimizes the delay for a given F. يعني أنا عندي أول stage قد إيه constraint لCG1 لإلها وعندي chain ما بعرف قد إيه كبرها وعندي C load here. Okay, I have C load here and now what should be N? Is N equal 3 the best delay? Is N equal 4 the best delay? Or what should be N? For this we will give you typically what we need now to do is really to do del TP star by del N, but this is a complex mathematical expression and هاي ما بقى فيها unknown غير ال N. Okay, so we will, here we're giving an example first. If I know that C load over CG1 is equal to 8, okay, and I want to evenly distribute this load over a chain of 3 inverters. Okay, so this means that F is the nth root of big F, which is the cubic root of 8, which means F is equal to 2. And if I start with the first inverter times 1 minimum size, this should be times 2, and this should be times 4. طبعا هاي بالنسبة لهاي هي times 2. But we're saying the absolute sizing of each stage هو حيكون times 4 compared to the first one. But if I know that the delay of this one is TP0, which is the intrinsic delay, or if I know the intrinsic delay for each one of these, then I know that the total delay in this case is going to be N times TP0 into 1 plus F over gamma. Okay, so now I know how to calculate the delay for each stage, and I know how to calculate the delay for the whole 3 stages. يعني هلأ صرنا عم نحكي على block level على higher level. I know TP0 is common to all of them. I know big F, I can find the little f. I know the number of stages, I can find the total delay. Okay? طيب, let us see what the slide is telling me here. So let me see how the slide continues. Okay, so this is telling me that C load over CG1 is equal to 8, that F is the cubic root of 8, and that TP star is equal to TP0 into 1 plus 2 over gamma. Okay, if gamma equals to 1, then this will be 9 TP0 and هتصير 3 في T0 TP0 ضرب 3. Okay, so for a fixed n, I know that I have, this is my delay. But what I don't know is that if I have a circuit with the same CG1, the same load, okay, if n equals 3 is really optimal or not. Okay, so لكن بما أنه n is TP0 into 1 plus nth root of f over gamma, for what we know or what we can guess is that for large n شو بيصير بال f to the power 1 over n؟ هيدي حتروح صح؟ nth root of very large n tends to infinity طار هيدا صح؟ So for large n the intrinsic delay becomes dominant. هيدا الترم بيصير dominant لأنه f to the 1 over n is very small. For small n the effective fan out becomes dominant لأنه typically capacitance بيكون large وهيدا الترم بيكون large. Okay. Now optimum n is found by differentiating TP star with respect to the number of stages. del TP star by del n equal to 0 وهيدا بس بتعطينا خلينا بس f is equal e to the 1 plus gamma over f. Let me just double check it from my laptop. Okay. So this will give me an expression where f is equal to 1 over 1 plus e to into 1 plus gamma over f. Fine. Okay, that's a solution that يعني we're not going to derive mathematically. Okay. طيب ليش؟ لأنه هو أخذ يعني من هيدا الإكسبريشن عمل differentiation بالنسبة للآن ولقى إنه هيدا differentiation بتعطيني this relation. طيب بس what this tells me we're going to take two values as a rule of thumb. إذا gamma equal to 0, this will tell me that f is equal to E اللي هي 2.67 something like that. And if gamma equals to 1, then we will have a solution for f. هلا بنشوف from the next slide. So according if I numerically draw f as function of gamma يعني باخد gamma 0, gamma 1, gamma 2, I will find the values for f. هون إذا gamma equals 0 قلنا f بتصير E. Now what I know is that f is equal to f to the power 1 over n. صح? But little f is E, so this is equal f to the power 1 over n. I take ln from both sides. اوكي وهيدي بتطلع ال E حتكون ضرب 1 over n. So حتصير ال n ln E اللي هي n ضرب 1 is equal to ln of big F. So إذا gamma equals 0 automatically I can figure out that n is equal to ln F. Okay. And now let us see if what are the other values. Okay, so for the other values here, what I have here is if gamma equals to 1, sorry, if gamma equals to 1, then if gamma equals to 1, my f is going to be equal to 3.6. So هيدا الفاليو حنستعمله وهيدا الفاليو فينا نستعمله. If gamma is any different, we will give you the corresponding f value, don't worry about it. But typically, we will either use this or this. طبعا نحن نستعمل gamma equal 0 لأنه ساعتها CD بيكون بيساوي 0. So typically most probably we're going to say that little CD equals little CG and F equals 3.6. Okay? طب هلا what this means is that F is equal to 3.6. This means that roughly each gate is almost sized 4 times as large as its predecessor. يعني يا 3.6 times يا 4 times. Okay, so each gate is sized 3.6 times as its predecessor. So let us take this number. يعني هيدا الفاليو ما بقى معتمد على ما بقى معتمد حتى على البيج اف، right؟ صار عم بقول لي انه independent of what you have if gamma equal 1, F is equal 3.6, and now where can I determine my n? ما أنا بعرف F is equal to big F to the 1 over n. صرنا بنحط هاي 3.6 is equal to big F إذا أنا عطيتكم هيدي 8 to the power 1 over n, and you can find n. قديش هلا حناخد examples. Okay, فإذا I use this and I use this fact in order to determine شو هي ال n, the number of stages. Let us see what examples we have here. طيب, here he's giving me one example, and in this example isn't n we're trying to find. Yes, we're trying to find n. Sorry بس مش مبين من الاسم الحط. Yes, we are trying to find n. Okay, what we did is we differentiated the delay expression, pardon me, we differentiated TP with respect to TP star with respect to n, حطيناها 0. هاي عطتني relation يلي بتقلي F as function of gamma, and then from this F as function of gamma I can use F equal F to the 1 over n. Based on my big F I would solve for my n. Okay?
Okay, thank you, Doctor.
Thank you. And now let us look at this example. هون عندي fixed C load على طول 64. يعني أنا عندي البيج F هي 64 CG1 على CG1 يعني هي 64. And he's showing me as I am adding inverters كيف الديلي حيمرق بالoptimal phase. مفرجيني as I increase n وين ممكن يصير optimal. Okay, let me ask you a question. If we apply the previous formula where we say little f is equal big F to the 1 over n, إذا اعتبرنا ال f تقريبا 4 وقلنا هيدي هي 64 to the 1 over n. Okay, what root of 64 gives me 4? يعني طبعا حناخد ln of 4 equal 1 over n ضرب ln of 64, بس إنه أنا بعرف إنه في عندي nth root of 64 بيعطيني 4 يلي هو what؟ or 3. let us say شو هو ال nth root لل 4 ضرب 4 قد ايه؟ 16 ضرب 4 شو بتطلع؟ 64 صح؟ Am I correct? Okay, so لكينا I expect around 3 stages will give me the 3 stages will give me optimal. طب هون هلا اجى حطلي ال n، حطلي ال f، حطلي ال TP على TP0. Okay, so let us see what is the relation that he is trying to follow, and then we will fill it on the next slide. طيب n هون هيني عندي هون أنا he forced 1 on me. Here he forced 2, forced 3, and forced 4. ال f حتكون ال nth root للبيج f. يعني ال first root لل 64 شو بتطلع بتساوي؟ 64 صح؟ السكند root لل 64 شو بتطلع بتساوي؟ 8 ب 8 64, so this is 8. square root يعني cubic root لل 64 تطلع 4. طبعا هيدي هي الفورث root لل 64. اوكي طيب هيدي بتطلع 2.8. اوكي so if we look here ما عندي شيء بس هيدا هي 64 ل 1. if I look here at those two طلعت عندي ال F8 so أول transistor size كان 1 هيدا هو 8 ضرب times 8 times right. so what is CG2 إذا CG1 هي 1 what is CG2 8 CG1 right. طيب هلا هون عطاني إياها 4x يعني إذا هيدا 1 هيدا 4 هيدا 16 لأن كل مرة عم بضرب ب4. okay يعني for example this one CG3 is equal to 16 times CG1. ليش؟ لأنه هون عندي ratio of 4 بين كل اثنين عندي ratio of 4. هذه هي 4 ضرب CG1 okay CG2 and so on. كل مرة السايز عم يكبر the capacitance proportionally grows by the same ratio. إذا بلشت ب 1 4 16 I end up with 64. The same for the last stage. طيب how do we write the equation of the delay? What is the delay? أنا بعرف إنه TP equals to TP0 into أو the sum of n times TP0 يعني صح؟ TP equals to للN هي n times TP0 into 1 plus F over gamma يعني TP على TP0 هي n ضرب 1 plus F over gamma. okay great. هون ال n equals 1 وال F is 64. إذا اعتبرنا gamma equals to 1 then TP على TP0 حتطلع بتساوي 1 ضرب 1 plus 1 اللي هي 2. okay so let us close this and see what the slide will give me. yeah عفوا 64 الF pardon me غلطنا. هيدي الF is 64. okay F is 64 for the first one gamma is 1. okay so خليني سكر هاي هلا. okay and let us come back here. so هون لكن عندي الإيكويشن ل TP على TP0 هي طلعت معنا from the previous slide. the equation for TP over TP0 was N into 1 plus F over gamma والgamma عم يعتبرها 1. okay so let us see هيدا 64 تطلع عندي 1 into 1 plus 64 على 1 تعطيني 65. now for this guy n equal to هيدي اتفقنا هي square root ل 64 اللي هي 8 وهيدي ال n هون هي 2 n into 1 plus f over gamma هي 2 into 1 plus f is 8 over 1 يعني 2 ضرب 9 اللي هي 80. okay for this one I had 3 stages. little f طلعت cubic root of 64 اللي هي 4 والديلي هو n into 1 plus f over gamma اللي هي 1. okay so هيدي هي 3 into 1 plus 4 over 1 اللي هي 15. okay so delay هون 15 and let me see the last one here هون 4 stages so it will be 4 into 1 plus f اللي هي 4th root of 64 اتفقنا 2.8 على 1 تعطيني 15.3. okay so as you can see here where was the optimal delay بلش كبير big went smaller. so this is the optimal delay and then it started to increase again. okay so if we compare this to the fact that we just talked about that when gamma equal 1 to find the optimal n we set f equal 3.6. if we say that f equal 4 if we set f equal 4 ساعتها أنا I can find 4 as the cube to be the cubic root of 64 and therefore n is equal to 3 لأنه أنا شو بحط relation هون حأجي أحط هيدي relation. حأجي أقول إذا اعتبرت f equal to 4 I'm going to write the following. I'm going to say 4 is equal 64 to the 1 over n, which implies that n equals 3, so the optimal number of stages is 3. فإذا هون حطينا لكل وحدة الإيكويشن اللي لها وطلعنا ال f given n. So here we say found f given n from the relation that f is equal to the nth root of big F. بينما بالoptimal case بالoptimal n بنحط gamma equal 1. بنكون عاطينكم نحن assuming gamma equal 1 شو هي optimal f, and from the relation of f and big F you find the optimal n. When you find the optimal n حتجوا ترجعوا تعبوها بالبلاي plug in its space. يعني حتجوا تقولوا هلا بناخد example تاني. حترجعوا تقولوا إنه TP على TP0 هي حتكون what would it be equal n اللي هي 3 into 1 plus f اللي هي 4 على جم. Okay, so 3 into 1 plus 4 على جم. Okay, so this equation always holds. This equation always holds. What differs is either I am given n and I use this equation. Okay, هلا بكتب لكم summary slide, or I find the optimal n. Okay, فإذا إذا بدنا نعمل recipe slide. Okay, what we see here is that case 1 n is given. Therefore, the procedure that I follow is that I say that f is equal to the nth root of big F, okay? And then I find that Tp is equal n times Tp0 into 1 plus little f over gamma. And in case 2, I have n, need to find optimal n. Okay, so in this scenario, given gamma equal 1, we will be given f, for example, equal 4. Then we will have the relation that f equal big F to the power 1 over n. We find n what is equal. And then we find the delay. It would be n times Tp0 into 1 plus f over gamma. Okay, so هو هن two scenarios اللي عندي هن chain of inverters. Clear? طب هلا in here in this slide they are giving me two scenarios. عم يعطيني بأول case إنه أنا عندي an unbuffered chain. In the second case عندي two stages chain. In the last case إنه أنا I have the optimal chain, and we are trying to compare the delay. So let us see how the delay drops first, and then we will write down the equations. خلينا نطلع هون. هون إذا كان عندي البيج F اللي هو very large load compared to the input capacitance. Look at the unbuffered. يعني أنا إذا بس حطيت one inverter driving this capacitor شو بيكون الديلي؟ إذا حطيت two inverters driving this capacitor شو بيكون الديلي؟ إذا حطيت n inverters driving this capacitor شو بيكون الoptimal delay. وإذا بتلاحظوا هون and we'll talk about how we derived these. Here the optimal n was 7. I added 7 inverters and the delay dropped from 10,000 to 33. So this is why the inverter chain is very important. يعني two inverters زادوني على 200, I dropped 200, which is good, great, but I can put 7 and drop the delay to more reasonable values. Okay? So هلا what I'm going to do is I'm going to take one example and work on it اللي هو when the fan out is 10,000. Okay, and we will look at this example here. Okay. Okay, so let us look now at the case where I have big F is given to be equal to 10,000. Okay, gamma is given to be equal to 1. And I have 3 possible implementations for my design. The first implementation is the unbuffered case. هلا هو طبعا عم يعتبر إنه عندي one stage يعني driving the inverter, the capacitor. So I have, this is my inverter. Okay, this is its input cap, this is its load cap, and this is CG1. And so the delay for one stage will be equal to TP0 into 1 plus F over gamma. So this will be equal, so therefore TP على TP0 will be equal to 1 plus F over gamma. What is F in this case? F in this case is equal to the nth root of big F, which is big F, right? So هيدا الديلي اللي كان حيصير بيساوي TP0 عفوا راحت في النهاية 1 plus 10,000 over 1 اللي هي تطلع 10,001 that we just saw a little bit before. Okay? Any questions? طب هلا هنطلع نحنا ال two stage. Okay, so if I have two stages now, what would happen? Let us see. So now I have two stage, and in this two stage I will have my primary inverter that has CG1. It is driving another inverter that is driving the load. Okay, n is given to be equal to 2. Therefore, little f is equal f square root of f, which is equal the square root of 10,000, which is 100 in this case. And Tp is equal ntp0 into 1 plus f over gamma. So Tp على Tp0 هي n اللي هي 2 into 1 plus 100 over 1 اللي هي حتطلع 202. Okay, which is what we saw in the table. شفنا إنه نزل الديلي من 100,000 10,000 from 10,000 to 202. Okay, now I want to solve for the optimal delay. So now I want to solve for the optimal number of stages. And in order to solve for the optimal number of stages, what I know بعرف CG1 ما بعرف قديش هن الان اللي حيكونوا هون, but I know that the big F in this example is 10,000. So لأني I'm searching for the optimal N, I can set the F to be given. Okay, so let us take for example that F is equal to 4. So let us assume that F is equal to 4 is given when gamma equals to 1. So this means that 4 is equal to 10,000 to the power 1 over n. And if I take the ln on both sides, okay, I will end up finding that n is equal to ln of f على ln of little f اللي هي 4, which is equal to 6.64 in this case. طبعا أنا I cannot have 6.64. I either round down إذا أنا بدي even stages لأعمل exact buffer. If I don't care for an exact buffer, يعني فيني أعمل inversion هون أرجع أدخل inversion مطرح تاني, then I find the closest. So let us say that we approximate the it by 7. Let's say that we round it up always. Okay, so in the exam I will be clear. I will say round to the nearest digit or round up, or assume you want to have a perfect buffer. Okay, طب هيدي الان صارت 7. هلا لما الان صارت 7 تغيرت الاف, صح؟ صار انا I need to هلا لاني عملت rounding to have a fixed number of stages, what I need to do here is I need to adjust F, يعني tune F. Okay, so F حتصير بتساوي هي ال nth root للبيج F. Okay, صارت هي هلا تغيرت شوي. It is going to be 7th root of 10 to the 4 يلي هو حيطلع عنا 3.72. Okay, هلا صار معي الآن Now I have my N, I have my adjusted F. I can now from here go and solve for what? I can solve for the delay. صار TP هو N times TP0 into 1 plus F على gamma, and therefore TP على TP0 is equal to 7 into 1 plus 3.72 over gamma اللي هي 1. فبيطلع عنا هون الديلي تقريبا 33.09 حسب التابل that I put for you. Okay? Anybody has any questions?
Doctor, could you please repeat what do you mean by exact buffer and why ISS we round up or down?
Okay, so when I am inserting a function إذا أنا حطيت هون 3 inverters. Okay, هيدي إذا أنا عندي signal A هون شو بيطلع عندي؟
A bar.
A bar. طيب لو أنا حاطة 4 inverters
A.
So إذا هيدي بنسميها buffer. هيدي بنسميها inverting buffer. لأن عم تجي ال A بس عم يطلع لي A بار منها. بينما هاي عم تجي ال A عم يطلع لي exactly A منها. أوكي؟
So it depends إنه إذا even or odd, right? إنه
صح. So هون أنا am rounding to closer. صحيح. So هون عندي أنا inverting buffer. لو أنا بدي طلع to the closest buffer كنت بدي أعملها round down على 6 صح؟ ليكونوا even. يعني هيدي odd هيدي صحيح؟
yes.
Okay, thank you. So let me go back to the slides. And we followed this example here. What we found is that if I directly plug in بدون rounding هيدا ما فيه rounding. Okay, هيدا فيه rounding اللي هو نحن we should adopt. Okay, and the numbers are close to this here. Okay, طيب so إنه فارقين شوي بس let us follow this table. Okay, you can repeat, you can practice on the other values and obtain the answers that you find here for each one of the different stages. Okay, طيب so هلا هون this concludes this section. نحن آخر 2 slides ما حنطلع عليهم 74, 75, 76. What I'm going to do is there is a small section on complex gates. If you remember the sizing that we used to do in 311. Yellow, one second, I'm trying to find where the lecture is. So I just want to employ it and it will come in the context of the Euler path. And it's almost a free question for you. Okay, so بدي مرقكم عليها I will record for you some problem solving that is related to it. Okay, so sorry, go to teaching. Some problem solving that is related to it. And let me just show you what I mean by the example here. And let me just 1 second open here the slide. Yeah. Yeah. Okay. So here is this set for the complex gates. Okay. Sorry, it needs 1 minute to load. Okay, if it doesn't load, I will go over it in the... Let me switch to the other file from the laptop, it's fine. Okay. Okay, so let me share the screen here. Okay, so if we so if we look at the sizing of the gates, if you recall from 311, and let me start from the beginning, sorry. We would like to size the NAND gate or the NOR gate to have the same sizing as that of the single inverter. Okay, هدول الgates that are here, what we have is that if I have the single inverter which has one pull down and one pull out, I want to make sure that the pull down, worst case pull down path has the same resistance in the NAND gate as that of the inverter. ونحن we studied from before أنه to balance the delay، يعني هون للNAND لحتى يعمل pull down I have two transistors that are running in series. For the inverter I have one transistor that is pulling down the output. So I want to make sure that RA plus RB has the same resistance as Rn for the inverter لحتى يكون عندي libraries are designed to have balanced delay، يعني pull down للNAND قد pull down للinverter etc. So we try to have them have the delay in a similar fashion. أنا بدي أعرف هلأ صرت إذا أنا عندي series transistors ولا عندي parallel transistors how am I going to size them. طيب إذا عندي 2 series transistor حيكون عندي RNA plus RNB بدي يساوي R للإنفرتر، يعني أنا عندي RA plus RB بتساوي R للإنفرتر، بس أنا بعرف إنه R proportional ل 1 على W، so بصير عندي 1 على WA plus 1 على WB هو بيساوي ال 1 على W للإنفرتر. Okay, so here if I want to make this إذا هيدا R يعني بدي أعمل هاي R over 2 وهيدي R over 2. This means that the W بما إنها inverse للwidth حتطلع معي بتساوي 2W. يعني if I want to resolve them equally WA equal WB حيصير عندي 2 على WA equal 1 على W، فتطلع ال WA هي twice the W of the inverter. So لكن إذا أنا عندي inverter transistors in series it is equivalent to their W's being in parallel، يعني 1 على WA plus 1 على WB okay is equal ل 1 على W للإنفرتر. okay، وإذا أنا عندي نفس الشيء بيطبق على السيريز، إذا أنا عندي parallel transistors فعليا أنا عندي هون resistors are in parallel. okay, so their width will be added up, their effective width will be added up. okay, so therefore the W, the effective W is the sum. هلا بالdelay when we do sizing we do not use the parallel branch. Typically مثل 311 what we do is we rely on the series branches, the longest path, and I size for a series path. What we are telling you on this slide is that if I happen to have two transistors switching in parallel, the resistance will be smaller and it is really effective as if I am adding the width of the two transistors. This is all what this slide is saying. أنا إذا عندي two parallel devices كأني عندي one bigger device. Okay, so they add up to one bigger device. But the sizing and in the delay, we typically deal with the series resistance لأنه نبلش بstack of inverter. يعني مثل ما عم نشوف هون إذا أنا عندي two series pull down path then I have to size it twice لأنه هي حتعطيني R over 2 والبلوت حتعطيني R over 2 and therefore accordingly I am going to have the pull down path have an effective resistance equal to R. okay, طيب the pull up path, the worst case path from the output to VDD بيمرق ب1 transistor, so I can size it similar to that of the PMOS. هلا مش عم نحكي هيك نفس الشيء بالنور جيت. بالنور عندها 1 pull down path فبيكون size مثل الأنوس. بالpull up عندي a series of 2 compared to 1. so إذا هيدي 2 هو بدهم يكونوا twice it ليعطوني ال RP، لكن أنا بدي أحطهم 4 W each one of them. Okay, so let me give you an example which we would like to solve. Forget about the annual delay and let us talk about this example here. I will give you problem solving that is clear on this. بس بهمني هيدا البروبلم هون. إذا عندنا نحن function okay like the NOR gate, then we are going to ask you to size the transistor such that the worst case delay is equal to that of the reference inverter, assuming that 1 corresponds to 1 micron. And then we're going to ask you for unshared diffusion, find the input capacitance and find the output capacitance. So what I'm going to do, I'm going to record some problem solving on this and another couple of other problems, but along this line, because I feel that these are questions that rhyme with the Euler, where you will be able to answer them easily, and this will complete info. طبعا